This is Unit 2, Day 2, Function Composition. A circular garden with a radius of 15 feet is to be covered with topsoil at a cost of $1.25 per square foot of garden space. Determine the area of the garden to the nearest square foot. Show your work. Okay, well, it's circular, so then you think area of a circle is pi radius squared. So now it mentioned to us that the radius is 15 feet. So I have pi times 15 squared. So you can go right to your calculator and you plug that in and you're going to evaluate that. And you get that the area is 706.858 approximately. And so then the nearest square foot, you find out that your area is 707 square feet. Using your answer from Part A, calculate the cost of covering the garden with topsoil. Show your work. Well, it's $1.25 per square foot, and you have 707 square feet. So you just multiply that, and you're going to get $883.75. All right. In example 9, we use the output of an area function is used as the input to a cost function. The idea can be generalized to I wonder if this will say generate functions f and g as shown in the diagram. Okay, so this is composition notation. One thing you have to realize is you work from inside out or right to left. So this is always done first, and then this f function down here would be second. Or if you're looking at this notation, this is done first, and then the f function would be done second. Okay, so here's my two functions. So again, you're going to work this first. So I'm going to do g of 1. So I'm going to come up to the g function. The g function is 2 times my x, which is 1, plus 3. Remember, this is my x value that I'm substituting in. And g of 1 results in a 5. Now you take that 5 that you just resulted that answer, and you're going to plug that in the f function. So you have to find f of 5. So now you're going to go to the f function and plug in a 5 wherever you see an x. So you're going to get 5 squared minus 5, which is going to result in 20. So the final answer is going to be 20. So it's like a two-step process. Moving down to b, you're going to go to the f function and plug in a 2. So f of 2, remember that's your value of your x, and it's going to be 2 squared minus 5, which is going to result in a negative 1. Now take that negative 1 and plug it in the g function, because that's what we're doing second. And you're going to get 2 times negative 1 plus 3, which is going to be 1. So that's my final answer. Part C, g of 0. So you're going to take a 0 and plug it into the g function wherever you see an x. So 2 times 0 plus 3 results in a 3. Now take that 3 up and plug it in the g function again, because it's g of 0. And that's going to be 2 times 3, which is 6, plus 3 is going to be a 9. Final answer. G of negative 2, evaluate that first. That's my x value. So it's going to be 2 times negative 2 plus 3 is going to be a negative 1. Now evaluate f of negative 1. And remember, negative numbers have to be in parentheses. So it's negative 1 squared minus 5, which is really positive 1 minus 5, which is negative 4. F of 3. So evaluate that first. Plug in 3 into the f function. So I'm going to get 3 squared, which is 9, minus 5 results in a 4. Now evaluate g of 4. So go to the g function, and you plug in a 4 wherever you see the x and evaluate. And I get 11. Last but not least here, f of negative 1. Again, make sure you're using parentheses around a negative number when you substitute it in. And that's going to give me a negative 4. Now I take that result, and I'm going to plug that in the f function again, because it's f of negative 1. That's how you would read that. And then I need to put that negative in parentheses squared minus 5. So I get 16 minus 5. It's going to result in an 11. Example 11. The graphs below are of the functions y equals f of x and y equals g of x. Evaluate each of the following questions based on these two graphs. Show your work. All right, so this is just learning how to read graphs. Now remember, f of 2. So that means go to the f function graph, which is over here, and go to x is 2. So here's where x is 2. You come up, and that's my answer. I get a 3, positive 3. Now I'm going to take that answer and plug it into the g function, which really means come over to the g function graph, and look where x is 3. So I come over to 1, 2, 3. Here's my 3. I go up, and my answer is positive 3. That's my final answer. Okay, so I'm going to do this again for you guys. So now g of negative 1 means go to the g function first and look where x is negative 1 and go up and read the y value. So here's where g is negative 1. I go down, so that's 1, 2, 3, 4. I'm at negative 5. So g of negative 1 is negative 5. Now I'm going to take that result, which is negative 5, and I'm going to go to a negative 5 on the f function. So 1, 2, 3, 4, 5, and I'm right there, which is negative 0.5. So that's my answer. I'm down negative a half. Okay, g of 0. So you got to kind of erase all the stuff that I've drawn. So on the g function graph, at 0, I'm at 0. So g of 0 is 0. Now, plug a 0, because that's the ending result, into the f function. Here's where it's 0, right here at the origin. You go up, and I'm at 2. So that's my answer. F of negative 2. Go to the f function and look at negative 2, and I'm up at a positive 1. Now substitute in g of 1, so go over to the g graph, and at 1, I'm up at 3. So there's my answer there. Last one here. Oh, I forgot part C, I'm sorry. G of 1. So I'm going to do that first. Go up to the graph and go to the g graph, the g function, and where x is 1, you're going to get a 3. Take that 3 and go to the g graph, the g function, and g of 3, if I go back up top, 1, 2, 3, I am at 3, and my answer is another 3. Okay. The last one here, you're going to do f of 0 first. So go to the f function and look at 0, and you go up and you're at 2. Now you're going to take that 2 and plug that in the f function again. So evaluate, go over 2 on the f function, and you're going to be at a 3. That's your y value. Example 12. On occasion, it is desirable to create a formula for the composition of two functions. Okay, this is a little bit harder. So determine the formula. So basically this says take the g function and plug it into the f function. So here's my g function. This whole thing has to be plugged into the f function. Okay, so that's going to result in 3. Now in that x spot, I substitute in the whole entire g function. And then I just have to simplify. So if I distribute, I'm going to get 15x plus 12 minus 2. One more step of simplification, combining like terms, and I get 10. So there's the formula. What this does is this is saying rather than doing 2 steps, you plug it into the formula and you get your final answer. Okay, now this one's saying take the f function and plug it in the g. So here's my f. I plug it into the g. So this becomes 5 times the whole f function, which is 3x minus 2. And then don't forget the plus 4 over here on the g function. So now I distribute, and I'm going to get 15x minus 10 plus 4. I combine like terms, and I'm going to get 15x minus 6. Okay. Example 13. if f of x is equal to x squared and g of x is equal to x minus 5, then, again, plug the g function into the f. So here's my g function. Plug it into the f. So basically, you have to take x minus 5 and square it. So for me, it's much easier to look at that written out as the product of two binomials, and then you're going to either FOIL or box. So my first term is x squared, my outer minus 5x, my inner minus 5x, and my last, don't forget, negative times negative is positive. Combine like terms, and I'm left with x squared minus 10x plus 25, which is going to be choice 4. Okay. All right, domain and range. Algebra year, you learned that the domain is always your x values and the range is always your y values. Okay, so your inputs are the domain and your outputs are the range. State the range and of the function f if its domain is in the set 1, 3. So basically, these are all the x's. They want you to plug them all in and tell me what the result is. So when you substitute in a 1, you're going to go 2 times 1 plus 1, and that's going to give you a 3. So it produces a 3 in the range. Okay? When you substitute in a 3, 2 times 3 plus 1, it's going to result in a 7. So that output value is a 7. When your input is a 5, it's 2 times 5 plus 1, which is going to be an 11. So my output, my range, is an 11. Show the domain and range in the mapping. Okay, so basically take all your x values, your 1, your 3, your 5, those are your inputs, or your x values. And what did you get out when you substituted them in the input? Your outputs were 3, 7, and 11. Now it does say mapping, so you basically say 1 maps to 3, 3 maps to 7, and 5 maps to 11. So there's my mapping. Okay, example 15. Determine the minimum and maximum values. Okay, x values. So looking on x goes all the way. Remember, x is left to right. Okay, so then you're just going to read that. This is negative 1, 2, 3. So it's all the way from negative 3 up until 1, 2, 3, 4, 5, 6. So my x's go from negative 3 to 6. So my minimum is a negative 3 for the x values, and my maximum is a 6. Okay, now we have to do it for the y values. So I'm going to erase this off here. Y's go up and down. The highest it goes is up here, and here's my lowest. Okay, so my lowest is negative 5, that's down there, and my highest is a positive 4. So that means min is negative 5, and my max is positive 4. Okay, so if you have a highlighter and draw those in, that's pretty easy. State the domain and range of this function using set builder notation. So here's how I tell you what set builder is. So for all the x values, such that it's going from negative 3 less than or equal to x less than or equal to 6. Okay, so that's basically reading that the x's go from negative 3 to positive 6. It's always less than or equal to. My y values go from negative 5 less than or equal to y less than or equal to positive 4. Okay, so that's set builder notation. Okay, these just talk about the parentheses and the brackets, which ones are included. So just make sure you really know the difference between, I call those square brackets, which means the numbers are included, and versus parentheses. Okay, make sure you realize that your infinity or negative infinity are never included. So that's why they're always smooth parentheses versus the square. Okay, set of all real numbers. Example 16. All right, which of the following represents its domain and range? So again, highlight. So the only thing you have to be really careful here, from left to right, these arrows are major. That means it's continually going to go wider and wider and wider. So it's all real numbers. So it's going all the way to negative infinity and all the way to positive infinity. So my domain, just looking at my choices, I know is going to be all real numbers, which is going all the negative direction in the positive. Okay, my range, remember, you highlight up and down. The lowest point is down there at negative 4, but then look, the high, again, arrows continuing, it's going to positive infinity. So it's definitely going to be my choice.